Welcome to the second part, Module 2.2, Linear Regression. So, we looked in the last section about how to diagnose whether we had a significant relationship between x and y, and we learned how to measure its strength, not only through a visual with the scatter plot, but also through the correlation coefficient r. And if we've decided that x and y have a significant correlation, and not only that their relation is strong, but that it's linear, we can actually create a equation which would be what we call our linear regression equation or our predictor equation. In order for us to look at a value of x and predict what a roundabout value of y should be given the behavior of my data. So we're going to go back to another set of x and y values where we have age and we have reading level. And we're going to look at the scatter plot, and if we look at that, we can see an apparent linear relationship between the two variables, age and reading level. So let's go back to our calculators, and with you, I'm going to go ahead and run this thing, and I'm going to make this a little bit bigger so we can see it. I'm going to move this smart thing over here. All right, so I'm still actually in our previous one, so I'm going to quit that, go back to stat, and we go to edit. Second quit is if you want to just clear out the screen of whatever you're in. I know that's one very simple thing that a lot of people don't know how to get out of the screen that they're in. In fact, we can always just hit stat. It'll take us right to this screen here, and I'm going to go into edit. So I want to edit these numbers. So I'm going to take out the numbers that I have. So I'm going to hit clear and then enter. And you do the same thing on your calculators. If you have numbers that you just don't want there anymore because we're about to put in some new ones, go ahead and clear those out. And here we're going to hit enter for list 1 my ages, so 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. We can see, I want to point out to you also that see that we're in this empty spot. We could put another number there, but we don't have any to put in there. But it says list 1, 11. That tells you that's 11th. This spot here is the 11th spot in the list, meaning that 15th is occupying the 10th spot. All right, going over to list 2, we're going to put in all of these different reading levels. We have 1.3, 2.2, 3.7, 4.1. Oops. And I made a mistake there. I accidentally hit enter instead of point. So I'm going to try that again. 4.1, 4.9, 5.2, 6, 7.1, 8.5, and 9.7 until I have all the numbers and I see that they're lining up. Just a quick look back at all my values. They seem to be correct. They're lining up with list 1 and list 2. So we're going to look at a scatter plot for these. We see that my plots are on. They will stay on until you turn them off. If I look at a graph, I can't see the points because they're off my screen. So I'm going to hit zoom, choice number 9 again, zoom stat. Oops, I think I hit something wrong there. I think I hit enter. So I'm going to try that again. Let's see, where was I? Oh yeah, we want to go to zoom, and then choice number 9. There we have it. So we see a strong, very strong linear relationship, though it's obviously not a perfect linear relationship. But we can visualize a line there. And if we look up the correlation coefficient, if I go into stat again, go over to calc, choice number 4, and down to calculate. We see, yes, indeed, R is 0.989 if we round it to 3 decimal places, which is a very strong correlation. And so we say, yes, there appears to be a very strong relationship here. since we do see a significant relationship between the variables, we're going to proceed in calculating a regression or a predictor equation for our variables. The regression equation is an equation of the line that best fits the points on the line. Looking at our graph again, you can kind of visualize a line passing through these points. Well, we want to find a line that's kind of right in the middle of all those points. That's an average of all the points. And in actuality, we're going to use our technology to find it. It's a bit of a complicated process, but if we look above the screen with r and r squared, in fact, go back to Stat and Calc and choice number 4, Linreg, you can see just with Linreg there that this is something that we already found on this screen. We just hadn't talked about it yet. Here we have our key here at the top. Y equals ax plus b, and then they're giving us a value for a, which would be the value we would stick in here in front of x, and then a value b, which would be the value here that we would substitute for b, leaving me with an x and a y. So we're going to go back to the slideshow here. This is my linear regression equation, and before I go any further, I'm going to go ahead, well, actually I'm going to go to the next slide first. We can see that this would be the linear regression for x and y. And I'm going to go ahead and put that into, if I go back to the y equal to screen, this is a screen where we can enter equations and see their graphs. So if I type in 0.865 and then we want an x, the button where we get x is this little button right here. You don't want to use the alpha or any of those letters there. This is always your variable button. So I'm going to hit x. And then minus, since it was a negative 3.811, I'm just going to put minus 3.811. One other tricky thing about this calculator is if you're wanting to hit subtraction, you want to hit this button. If you're meaning to indicate negative, you want to use this button. You will always get errors if you use subtraction in place of a negative. We don't want a negative here. And that's one of the quirky things about it. One of those things where I have a lot of students who will say, I don't understand, I'm getting an error. And it's because they used minus instead of negative or vice versa. So now I'm going to hit graph, and what this does is we can actually see the equation of best fit, the predictor equation, the regression equation, the line that best fits these points. So the regression is an equation that we can be used to predict the value of any y for any given value of x. Again, it's just an estimate, but it is our equation of best fit. What our calculator is doing is it's taking all these distances from these points to the line, and it's calculating a line that has the least amount of distance total from all the points. And that gives you an appreciation for this very expensive calculator that we use. So a couple things about this regression equation. Number one, we have to have a statistically significant correlation. In other words, we have to have a really good R in order for this predictor equation to really be effective. Also, the predictions need to be made within a given range of sample data. So you do not want to stray too far to the left or to the right of what the data is that you're given. Now, our ages that we were given, in other words, our x's, we're going from 6 to 15. So I don't want to go too far outside of that. I might be able to get away with going to 16 or 18 or going down to maybe 5 or 4. However, once you start getting out of your range of data, we don't really know what happens to these points. At some point, if I went up to 24, that would be way out here for x, and I don't know what y is going to do. We know that at some point it may level off. We don't know. And so if we go too far outside of the table, that's called extrapolation. And that's something we want to avoid because it tends to give us outcomes that are not really reliable. Also, we want to make sure the population that we're substituting in for X is the same as our sample data. So these are ages of children. We probably would not want to substitute ages of dogs, right, in for X and expect to figure out what the reading level is for our dog, because this equation is based on ages of children and their reading level, and hence we wouldn't want to predict their math level given their various ages, because math was not a part of this data set. All right, so you want to make sure that your population is the same as the data, so your x's and y's are the same. You want to make sure you're staying within the given range of your sample data, relatively speaking. Don't want to go too far. That's called extrapolation. And then you want to make sure that your correlation is significant. The fact of the matter is we can get a set of points that's scattered all over the place, and our calculator will find a regression equation for it, whether it's statistically significant or not. So we can make wrong predictions because our original data was not statistically significantly correlated. All right, we're going to go on to the next slide here. So for our regression equation, let's say, let's predict the value of reading level of a child that's 11.5 years old. I want you to put that into your calculator, predict it. Pause the video while you do that. Again, age is our x, so we're putting it in for x here, and then we're just doing the math. We're going 0.865 times that value minus 3.811 to get a result. The result you should get is a reading level of 6.1365. For a child who's 9 years old, go ahead and calculate that. All right, our result there is a reading level of 3.974. And last but not least, let's calculate the reading level of a child who's 18 years old. Okay, the result you should get there is 11.759, but then I have a but there. So remember, our ages ended at 18 or at 16 for our data. We may not want to use that number. It's kind of up to your own discretion there, because it may not be reliable. We all know 18-year-olds. Sorry to anyone out there that's 18. But you know, the main part here is we may be doing some explanation there because we may be going outside too far from our data values. We could also do it the other way around, and you want to pay attention, especially on your homework, that sometimes they may give you the predictor value y and they want you to find x. Remember that this is our dependent or response variable. I may have said predictor variable there. That's incorrect. This is our response variable, and you may be given the response variable, and they may be wanting you to find the causal or the predictor variable. In that case, we're just substituting our number over here, and then we're doing the algebra to solve it for x. All right, so finally here, we have some data. I want you to clear out your screens and go ahead and figure out which one you think is a predictor, which one is the response. Plug those into your lists, and then find the appropriate number regression equation. So find the regression line, and then use the regression line to make a prediction of the recovery time for someone with a fitness level of 5.5. That is the end of our presentation. Thank you for watching.